Bismillahirrahmanirrahim. So welcome to Discrete Mathematics class. So today we are going to study about fundamental algorithm, integers and matrices. So in today's lecture we will be just study about algorithm and integer, and matrix we will be studying in next lecture. So what is algorithm? So you guys writing a program in your C++ in or Java and object-oriented programming, so you guys using a algorithm there. So we will see here how algorithm works, how we can write algorithm. So coming to the algorithm introduction, so just keep in mind, algorithm, a procedure that follow a sequence of a step that lead to desired answer. What does it mean? Let's say you have a number 1 2 3 4 5 6 7 8 9 10. In 10 number, somebody is telling you that find a number 9. So when you are going to find a number 9, so it means you are going to do a stepwise process, then you can get a number. So this is a kind of a procedure, and we can say it algorithm, how you can find a desired answer. So definition of algorithm can be: an algorithm is a finite set of a precise instruction for performing a computation or for solving a problem. Okay, it's so easy, just simple. What does it mean? We will have a finite set. Through a finite set we can find our solution. What kind of a question we will have it in a book, in an exam, so we can find it by using algorithm. Then for example, describe an algorithm. Now we are going to find an algorithm. Describe an algorithm for finding the maximum value in a finite sequence of integer. Let's say we have a number 1 2 3 4 5 up to 20 up to 30 up to 40 and so on. We have but a finite number. The finite means the last number will be none. So we need to find the largest number from a sequence. So what we can do first, the stepwise. So this step is called algorithm. Now the first we can see, we will define a temporary maximum number. We will say okay, A1, yeah, A is maximum temporary. If it's not A, it will be compared, and if let's think, we have a A1 and A2. If A1 is greater than A2, it means A1 is a largest number. But if A1 is not greater than A2, it means A2 is a greater than, we will take A2 is a maximum number. Then A2 will compare with A3. If A2 is greater than A3, it means A2 is your greater number. Otherwise A3 is your greater number. So then A3 will compare with the A4, and A4 will compare with the A5, and so on, up to we need to find a greater number. So this is step. So first you need to assign a temporary maximum number equal to the first integer in the sequence. The temporary maximum will be the largest integer examined at any stage of the project. At any stage of project mean it will be compared with each number. If this temporary number is a greater than other numbers, that will be your maximum. Otherwise the greater number will be your temporary, then it will be compare up to extent, then you can get your last maximum number. So this is one of first one. So you need to assign a temporary maximum number. Compare the next integer in the sequence. Again the same thing, comparing it, next integer in the sequence to temporary maximum. If it is a larger than the temporary maximum, then the temporary maximum equal to this integer means if A1 is your temporary maximum number and A2 is your next number. If next number is greater than the temporary, so it means A2 is your temporary. Now then A2 will compare with the A3 will compare, and so on, up to you need to get your maximum number from the question. Okay, then step 3, repeat the previous step. Like this step will be repeat up to you get a maximum number. if they are more than an integer in the sequence. So then in the last one, stop when there are no integer in the sequence. The temporary maximum at this point is the largest integer in the sequence. It means, let's see, a is your temporary number and a1 is the largest number, and throughout the comparison a1 is the largest, so it means stop your process and a1 is your largest number. Let's see algorithm now, how we can program it. So algorithm of this, so an algorithm can also be described using pseudocodes. You know about a pseudocode, and intermediate step between an English language description of an algorithm and implementation of this algorithm is in a programming language. So we will be use this algorithm in English languages, so that can be in a programming language. Having a pseudocode description of the algorithm is the starting point of writing a computer program. So now we are going to make a program for the temporary maximum. Let's see. Algorithm 1 is find the maximum element in the finite sequence. Find the maximum element now. So procedure is, first of all, you need to assign maximum is a1, a2, a3 up to an. N is your last term, which is finite, which is defined, which is noun. So that is called integer. So from this now we can get a maximum number. So let's see, we are considering maximum. This is whenever you are writing a program, so you can use this term with every number, with every word. So max is equal to a1. Let's see, a1 was temporary maximum number. First of all, max is equal to a1. So for I is equal to 2 to n. 2 to mean I will be 2, then I 3, 4, 5, 6 up to n, into I will be n. So I start from 2 to n. So f, now we are comparing, f max is greater than ai. Ai mean it can be a1, it can be a2, a3, a4, a5, but a1 we consider it, a1 is your temporary maximum number, so it will be start from 2. So f max is greater than ai, it can be a2, a3, a4, a5 and so on. Then your max will be ai. The max, f max is less than ai. What does it mean? Max is less than ai mean your a1 is less than a2. Let's see. So it means this a2 will be your maximum now. So it means your ai is your maximum number. When ai is your maximum number, so we have other number as well. Then compare again. The a2, now a2 is your max now. So a2 will compare with a3. If a3 is greater than a3 is your max, then a3 will compare up to the last. You need to find your maximum number. So max is the largest element. This is a comparison how you can find your maximum number. Just take a 1, compare it, is your temporary, then a2, a3, a4, a5 and so on. Then the last term you need to find which will be the maximum. If this a1 was a greater than, if this we said that a1 is greater than a2, so and same a1 will be your max number. Then a1 again compare with a3. Again, if a1 was a greater than a3, then a1 will be your maximum. If a1 is greater than a4, then a1 will be again the max number. So and so on. This is the way of algorithm. So now coming to algorithm steps in this, as we solve a program. So several property algorithm generally shared, like we have an input and algorithm has an input value from a specific set of output from each set of the input value, and algorithm produce output value from a specified set. The output value or the solution to the problem. Definitely the step of an algorithm must be defined precisely. Correctness in algorithm should produce the correct output value for each set of input value. Finiteness, algorithm should produce a desired output after a finite number of a step for any input in the set. So effectiveness, it must be possible to perform each step of an algorithm exactly in a finite amount of the time. Generality, the procedure should be applicable for all problem of the desired form, not just for a particular set of input values. So we did algorithm for a maximum number. Now we are doing a algorithm for a searching, linear searching algorithm. Okay, so searching algorithm, like you know what to search, you need to find a specific word, specific number. So locating an element x in the list of a distinct element, this is your list. You need to find a distinct number or determine that it is not in the list. Example, search for a word in a dictionary. So it's a searching. Now find a student ID in a database table, it's another kind of example. Determine if a substring appear in the string, it's a like example. So now the thing is the linear search, how it came, sequential search. So now it's very simple. Begin by comparing x and a1. So when x is equal to a1, the solution is the location of a1. Namely, when x is not equal to x2, the compare x with a3. Continue this process comparing x successfully with the each term of the list until a match is found, where the solution is the location of that term. If the entire list has been searched without locating x, the solution is 0. What does it mean? Let's say you are going to find a3. So you need to compare a3, like x is your a3. So x will be compared with a1, x will be compared with a2, x will be compared with a3, a4, a5. When x is equal to a3, when x is equal to the same, when x is matched like this, when x is matched in your sequence, it means you find your desired solution. So that's why you need to be compare. So if you didn't find, so your solution will be 0. So this is a question now. So now we are going to find the algorithm for this searching. So this is so simple. So the algorithm number 2 is the linear search algorithm. So procedure is like linear search is x is integer. So a1, a2, a3 and up is your set, finite set, and we need to find a distinct integer. So we say that I is equal to 1. So while I is greater or less than n and x is not equal to ai. Okay, so what does mean x is not equal to a mean? So okay, we need to find a next number. So how we can find a next? So I equal to this I plus 1 mean, first of all I was 0. Let's see, I was 0, so x was not equal to ai. So we need I1 now. So 0 plus 1 is your next, then 1 plus 1 will be another number up to extent you need to find your desired. So f, this is your loop, basically while loop. So while I is less than or equal to n and x is not equal to I, so go ahead this point. This is basically a method of loop. So if I is less than or equal to n, okay, and x is not equal to ai. If x is not equal to a, then jump to this point. But if I is less than or equal to n and x is equal to ai, so no need to be jump to this point, then directly jump to this point. This is basically a step of algorithm. You guys know about that because you studied in programming as well. So when x is not equal to I, so go ahead to this step. Then if I is less than or equal to n, then location is I. What will I mean? I will be 1, maybe a1, I will be 2, maybe a2, maybe a3, because if this is not equal, then it will be I2. If this is again not equal, maybe a3, maybe a4, maybe a5, and so on. So up to a last term you need to find a comparison, you need to find your distinct object. So if you didn't find this, if you didn't find it, then your else location will be 0, mean you don't have a matched number in your sequence. So you guys need to be understand this kind of programming. So try it a couple of times and you will be understand it. So it's a while loop. If I is less than equal to then x is not equal to I, then go to this step. Then after that you can come to this step. If you find this, if you find the location, it will be your answer. Otherwise your location will be 0 because you don't have it. But if I is less than or equal to n and x is equal to, it's equal to ai, then no need to be jump this step, just directly jump to this one and your solution. No need to be write this one as well, because it's a comparison and it's matched. When it's matched, so no need to be jump to the other steps. So coming to binary search. So algorithm for a binary search. So it's again the simplest. The algorithm is used when the list has a term occurring in order of increasing a size. Example, smallest to largest for a number, alphabet order, or for a word, etc. It proceeds by comparing the element to be located to the middle term of the list. The list is then split into two smaller sublists of the same size, where one of the and so on. So I'm just telling you the example. We have an example and we have a sequence of this term. This is our sequence. So we need to find a 19. Need to find a 90. So first of all, what we can do, because it's a list and we need to find a number. So first of all, divide this sequence into two half. So again, 8 number will be here, 8 number will be here. Okay. So when you divide the sequence to two half, then compare your 19 with the largest value of this sequence. So your largest value of this sequence is 10 and this is 19. So if you compare 19 with the 10 and 19 is greater than 10, it means your 19 will not be here. So it means your 19 will be here now. Okay. So then take this list and again divide into half. Then divide into half, 4 will be here, 4 will be here. Then again the same concept. 19 from here and the maximum number from this one. So 19 is greater than 16. So again it means your 19 is not in this list. Then divide this one again. So when divide this one in the 2, so 18, 19, 20 and 22. So 19, this is your maximum. So your desired number was 19, need to be find as you need to search a 19. So 19 need to be compared with the largest number of this one. So 19 with the exclamation, it will be it's equal. So no need to be again divide or half it. So it means your 19 and 18, and 19 is greater than 18. So use the second half, only one element, compare, get the location. So this is basically a method. So the same procedure we are applying in a programming way, in algorithm way. So now coming to the algorithm of a binary search. So simple is procedure is binary search. X is your integer is x is your 19. So a1, a2 and 3, it's your basically a sequence. So you need to find a 19 from a sequence. So this is called increasing integer. So keep in mind about that. So we need to define two terms first. I is equal to 1. What does this mean? I is the left end point of a search interval. Left point, we had a 16 term, 8 from a half side, left side, and 8 was the right side. So left side is your I. J is equal to n. J is the right end point of a searching interval. So it was the right side and the end point. So it means I is the starting point and J is the end point. So I mean I want to what was your last term here? 22. Okay. So now we need to find a algorithm and programming for it. So you know, first of all, I is less than j. So while I is less than j, then you can start your program in this way, because we know I is your left side and j is your right side, and I was your smaller values and j was your greater value. So I is less than j, then begin m is equal to, what does it mean now? I plus j divided by 2. It means take all your sequence and divide by 2, mean make it in a half to the right side and half will be the left side. So okay, up to this season you get it. Then if integer 19, if 19 is greater than am mean, now you can see am mean your a1, a2, a3, a4, a5 and so on. So if 19 or integer x is greater than am, so it means your integer is not in the left side. So then I will be m plus 1. M plus 1 mean, so it will be I2, because if m was 1, a1, then x is greater than a1, so it means it's not true. Then you will go to the next term. So then m was 1, so 1 plus 1 2, so your position is now I2. So then you can search A2, A3, A4, A5, A6, A7 and so on. Then if x is greater than am, so then you can jump to this point, otherwise your j will be m. What does it mean? Your j will be m mean this is your half and this is your half values. Okay, if this x19 is greater than this value, so it means your value is not be here, so you can jump to this one. So if x is greater than am, so then you can jump to this one. So then you can compare your x in this sequence and follow this loop. You know about the loop. If you didn't find your number in this sequence, in this left sequence, then you can go back and again search. Again you didn't find, then you can go back. So this is the basically procedure of programming. Then that if x is greater than am, so it means it's not true. Then jump it again, then find, jump it again mean j is equal to m mean. So now you can jump from this sequence, you can jump from our left sequence to the right sequence and divide your right sequence into half, then compare with the am. If again you didn't find, then jump again and then divide this two half into again half, up to instant that you will find your desired value, your desired integer, like x was your 19, let's see. And okay, then after that your while loop will end and you get your desired value. Then f x is equal to ai. F x is equal to ai mean your position will be known. X is equal to I mean your integer 19 is equal to 19. Then because ai is your number, ai is your position, ai mean a1, a2, a3, a4, a5, a6, a7, a9 up to last term. Okay, then if x is equal to ai, then your location will be I, your location will be I. So this is, otherwise if it's not equal, then your location will be 0. It means your integer is not in the sequence. So how does it mean by ai? So this is your a1, a2, a3, a4, a5, a6, a7, a last term. Then up to this term you can find which number is it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So a14 is your desired number, or I is equal to 14 is equal to is your desired number. So this is the algorithm. So it's not easy, you can try it couple of times and need to be understand it. So now coming to another algorithm of sorting. What is sorting? So you know about the sorting, which is so simple, to arrangement from smaller to higher value or higher to smaller value. Okay, so you have this question. So for example, use the bubble sort to put 3, 2, 4, 1, 5 into increasing order. You know about bubble sort in your, you studied in programming in C++, in object oriented programming. There is a bubble sorting as well. So we have a number 3, 2, 4, 1, 5. 3, 2, 4, 1, 5. It's not a sort. We need to sort from 1 to 5. So this is a method how we can 3 will compare with the 2. So 3 is greater than 2, so 3 will be here, then 4 will compare and 4 will be. So this like one by one step it will be go up and will be come down and go up, come down up to the last value to find your desired sorting sequence. So now we need to find a algorithm for it. So algorithm for a sorting, it's very easy and very simple. So algorithm, the bubble sort is another algorithm. So procedure of bubble sort like a1, a2, a3, n is your real number and n is greater than 2. Okay, what n is greater than 2 mean? Your first term or your in a sequence, your number is greater than it. If you have a 1, so it means you are already having a sorting value. So let's see, for I is equal to 1, for I is equal to 1 to n minus you are less than a last term, because if last term is your smaller, then again comparison. If last term is your greater, then no need to be compared, because already you have a greater number in your last. So I is equal to 1 and I start from n to minus 1. For a j start from 1 to n minus 1 again. So we have I and j, need to compare I and j. So if aj, let's see, aj is greater than aj plus 1. Aj mean, let's see, you have a aj, let's see, j is 1, so a1, then aj plus 1, so it mean aj plus 1 mean, so j was 1, so 1 plus 1 is 2. If your a1 is greater than a2, a1 is greater than a2, then interchange the position of aj to aj plus 1. Mean a1 will be in a position 2 and a2 will in position 1, because a2 is a smaller. It's just like this one. So interchange the value and so on. So at the end, automatically by this loop, you get your sorting value. So this is simple programming for this sorting. Try it, it's very easy, just comparison. So a1 is greater than a2, then a2 will greater than a3 is greater than a4 is greater than a5. So just simply interchange the position. If the position if aj is less than, let's see, if a1 is less than a2, then it will be on the same position. But if a1 is greater than a2, so then it will be interchanged. So this is a simple way of sorting. So hope you guys understand it. So again, the same algorithm of inserting sorting. Again, the same one is how you can get your value from a sorting. So I hope you guys can be studied by yourself. It's so easy because it's same like a sorting well. So again, algorithm number 5, the insertion sort. Procedure insertion sort a1, a2 and real number is greater. Again, for j is equal to 2 to n. Okay, begin I start from 1 while aj is greater than ai. This value aj is greater than ai, so I will be I plus 1. If this satisfied, so then it will be come to this one, then I will be 2, because I1 a is equal to 1, like a is I and I is equal to 1, so it means a1 is greater than ai. It's just like, because j is greater than, so sorry, a2 is greater than a1. So then jump to another one, so it will be I plus 1 to 2, so I will be 2, then a2 is greater than, so it will be a3 now, because stepwise. So a3 is greater than a2, because just putting the values. Okay, when it's satisfied, then m is equal to aj. So for k is equal to 0 to j minus 1, j minus I minus 1, then aj minus k is equal to aj minus k, and so on. So this is basically how you can insert a value in a sorting. So this is simple. So hope you can try it by yourself. So integer and algorithm, so it's a simple one, you know about that, how you can find the decimal number, how you can find a binary number. You studied in your computer architecture and digital logic designing, in the data communication as well. Again, the same one, it's your hexadecimal number convert to the decimal number, then it's your decimal number convert into octal number, and this is your decimal number converted to hexadecimal number, and you study that. So this is basically algorithm. And then integer and algorithm, it's just like addition of a binary number. So algorithm for integer operation, how you can add. So again the same procedures here. Integer and algorithm example, following the procedure specified algorithm to add a, again same addition. And then the product of a binary number integer, like it's a product, and again it will be product of these two. So up to this you guys can study it, need to understand the algorithm of the procedure, how we can make an algorithm for a programming. So we study about couple of algorithm. So hope it will helps you. And if you guys find any question, so you guys can ask. I will try to explain this in a better way as well. So but actually this lecture is related to your programming basically, because in a programming you have an algorithm how you can find a bubble sorting, how you can find a maximum number, and how you can comparing a two number. So it's the same in you studied it in a programming. Hope you guys can be understand it in a better way. So thank you for your time. So see you in our next lecture.